Hi, in today's presentation we are going to do a walkthrough configuring one of our BRS switches. The BRS has the iOS operating system on it, which is the newer chipset that Hirschmann is using in their switches. And the first thing that we're going to do is we are going to go to the customer support portal, and we are going to download the High Discovery application. And the High Discovery application will allow you to find the switches, identify the switches, name them, assign an IP address to them, and ultimately then also with that IP address be able to log into the switches. So first thing is our customer support portal. It does require a login account, and this account takes maybe a minute to create. Once you've created this account and logged in, you can go to the download section, and in the download section go down to the High Discovery section, and you will want to download the latest version of High Discovery. The latest version currently is 2.3.01. When you've downloaded this, go ahead and install this. And also, while you're in the customer support portal, you'll note that this is also where you will find our firmware for our switches. So currently the latest version for our firmware is 9.1. This is what we're currently utilizing in this demonstration. And here too you will find all of our other software, including our NMS. This is Industrial High Vision, our network management software application. This does require it is a paid-for software application, whereas High Discovery is free. We then also have things like our CAD files on here for all of our products. We also have manuals, and we also have Visio stencils. Additional documentation can also be found under our documentation portal, and these links will be provided separately. And within here you will find all of our manuals, even more detailed than you will find in the customer support portal. And in this link you will also find features based upon the product family, as well as the management feature set of those. So our management feature set for iOS spans Layer 2 Standard, Layer 2 Advanced, Layer 3 Standard, and Layer 3 Advanced. And you will find that not all of the switches have exactly the same feature sets. So for example, if you are looking for IPv6 management, it is not found in these two products here at a Layer 2 Standard rev. So this comes in very handy when looking for certain features, and you'll notice that it too will highlight, indicating the specific switch or product family. For example, an RSPE gives you a visual indication as to where you've clicked and what you're looking for. So it's a very handy tool. So now that we've downloaded High Discovery, we're going to go ahead and install it and launch it. And the benefit of High Discovery is that it is subnet agnostic. So I've made sure that I've selected the interface that I'm currently plugged into the network with, which is this interface connection right here. So I am on a 192.168.1.99 address, and you'll see that I've been able to find other switches on the network. These are all Hirschmann switches, some with an IP address that's in a different subnet, some in the same subnet, and ones that don't even have an IP address at all. So in this case, what we're going to do is we are going to take these two switches right here, and these are the two switches that we are going to now address. And just to make sure that these are the right switches, I have the ability of selecting a switch and then signaling it. And a quick look, yes, the LEDs are blinking back and forth, so I do know that this is one of the switches that we're going to address. And if we will call this our switch 1, I can double click on it and now name it. So switch 1, and I want it in the same subnet. So what I've done is I've previously created a default. So what you do is you populate these fields, click on this, save as default, and then the only thing that you need to do is address the last octet. So in this case, I've already given this one an IP address. We'll now proceed to this one. Make sure that the LEDs oscillate on this one. So yep, this is the right switch. And we're now going to address this one as well. This is going to be a .20, and this is our switch 2. You'll see that there's actually a conflict here. So let me remedy that. We will make this a .21. Do a quick rescan. Oh, I'm going to have to restart the application. And now there are no conflicts, and again we have our switch 2 and our switch 1. Make sure these are the right ones. Yes, and yes. Okay, so that done, and because they're also in the same subnet, we'd be able to ping them. And what we're going to do is we're going to open up a web browser. These switches support HTML5, so any web browser should do. And it's going to give us a security warning because these are self-signed certificates. And we end up with a login screen. It'll note the management feature set. It's a 2S switch on a firmware rev or firmware rev 9.0. So I was actually corrected. This is not a 9.1 firmware. It's a 9.0. But we'll go in with admin and private, and these are the default read-write credentials for all of our switches. So with that said, it's now going to force us to go ahead and change the password, and I am going with what is not a recommended best practice, because I'm going to reuse the same passcode. And we're going to go back in with admin and the changed password. And here we have our login screen, or our dashboard for the switch. So this is under Basic Settings System, and you'll see the entire menu structure over here on the left hand side. Again, it'll display the management feature set, and from here I can also filter. So for example, if I'm going to look for anything having to do with VLANs, simply by typing in VLAN, it will bring me up anything and everything having to do with VLANs. If I were to type in IGMP snooping, this is where you would then find IGMP snooping, or mirroring. This is where you would find the ability to then mirror your ports, and so on and so forth. But starting from the very top, we're going to start here with the system. Anything that is underlined is a user definable field. This includes the temperatures, and these temperatures obviously can be monitored, and they also can be alarmed upon. The switch can automatically send out an SNMP trap upon any event that you may have. Also, these values all have MIBs that can be monitored and incorporated into your automation software. Going down the menu structure, actually before we do that, let's address some of these tabs, or these green and red indicators up here. Obviously green, good; red, bad. And here we have device status. These all can be custom tailored, the alerts. So device status, there are no alerts here. There's also, it does show a single status for the signal contact, but it's non-critical, which is why I'm assuming it's not red. And we will look into seeing exactly what is behind this a little bit later on in the diagnostics section of this presentation. Next we have the red security status. Obviously the very first alert is because I have not changed my default password. I changed it back to the word private. It is also not following the minimum password length, which is 8 or more. The HTTP server is still active. I'm currently connected through HTTPS, and so on and so forth. So all of this can be tailored to a customer's or your specific need, and then applied to the entire rollout of networking gear that you may have. Next we get into network under global. We show that the management interface is running on VLAN ID 1. This can be changed. One needs to create a VLAN first. So if I were to go into VLAN global configuration, and I would then add a VLAN that is a separate VLAN that I can then go back into here with, and I can then apply a different VLAN. It's then going to ask me also as to what port I would want this this separate VLAN on, and I would then identify the port that I'm currently connected to on that switch, and this is how I would then place my management VLAN in a different VLAN ID. Here I also have the ability to either completely disable the high discovery protocol, or better yet, this is my recommendation, is to make it read-only. If I make this read-only, and if I click on the apply down here in the bottom corner, and I don't want it to go to VLAN ID 10 just yet, but I've now changed the high discovery protocol to read-only. What this has in terms of an effect is that if I were to then redo my scan, it will still find all of the switches, including the one that I'm currently logged into, but you'll note that the writable check mark in this little radio button here has been disabled. This means that while I can go into this switch to change its IP address, I can go into this switch to change the IP address, but I cannot go into this switch to change the IP address because of the fact that I have made this read-only. So again, in terms of a best practice, changing this to read-only when you're done assigning IP addresses is a best practice, as it also prevents someone from possibly changing the IP address utilizing the high discovery tool. Next, we go into the IPv4 management interface. We can either do static IP address, which we've done right now, but we also support BOOTP and DHCP. We also have in the BRS and the BOBCAT series, we have a USB-C out-of-band management port. And what this allows you to do is this allows you to go into the switch with just a USB-C connection, which actually you see right here. And what this allows me to do is this allows me to access the switch out of band. This means that I can access the switch, but only the switch. I am not on the network at that point. And to illustrate this, what I'm going to do is I'm going to unplug both connections of this switch, and I will take this USB-C cable, and when I plug this in, Windows is now going to emulate this as a network connection. I don't need to make any routing adjustments or any IP addressing adjustments. All of this is done within Windows, and it is an emulated network connection. So I'm in the switch. And because this is the switch that I was just in, this one right here, I am now going into that same switch, but only going in through this USB-C connection. And this is no different than me being on the switch across the network, except I'm local, and I am out of band. There's no possibility for me to get onto any of these ports and onto the network. I'm exclusively in the switch management in this switch. And plugging back in, and there's a strong likelihood that the switch is probably going to give me some grief because I'm now connected to a different port. So let's see if we can do a refresh down here at the bottom, and yes, it's going to require me to log back into the switch. And as you can see here, I can either enable this or disable this. It is enabled by default. You can also change the address of this USB-C port. So it has a lot of flexibility, but it does require local access. Next, we come to the firmware or software, and this is simply a matter of dragging and dropping the bin file of the software package or firmware package that you would like to load onto this this switch. So in this case it's 9.1. You'll notice here that the switch is currently running on 9.0. So we're going to do this update, and it's going to take about 1.5 minutes. And what we're going to do is I'm going to fast forward this to when it's done loading. Okay, so total time was just a little over 1 minute, maybe 1 minute and 20 seconds. So software's been successfully updated on the BRS. And when we do a refresh, again, make sure that you use the refresh down at the bottom right hand corner. If I do a refresh, you'll note that the running version is 9.0.02. The stored version is 9.1.00. This means that the switch has the firmware updated, it's stored, and to apply this new firmware to the running location or running memory allocation will require a reboot. And reboot can simply be done by pulling the power and simply power cycling the switch, or what you can also do is you can go to the restart and then do a cold start. So we're going to go ahead and do that, and once this switch is back up and running, we will resume this. And here we go, we're back at our login screen. It was almost 1 minute 20 seconds, and we're going to log in with admin and our super secret private passcode. And before we do, you'll already notice that it's now running on 9.1. So it's taken on the new firmware, and when we log in and we go back down to software, you'll notice that the stored version is now the same as the running version, with the previous running version having migrated over as a backup version. So if we ever wanted to revert for whatever reason, it's as simple as clicking on this button right here. We also will see that down here at the bottom we have different revs, so we can have multiple revisions of our firmware in the switch. Going over to the Load Save tab, we will see that we have what's referred to as an external memory. The external memory, probably better yet, let me start off with the memory types that we have in this switch. So obviously we have what's known as our running configuration. Our running configuration is in RAM. This is volatile memory. This means that if I power cycle the switch after having made any changes, I will lose those changes, which is why we also have non-volatile memory. So anytime that you make changes, do make a point to click on the Save button down here. When you see a floppy disk symbol with an exclamation mark, and if you hover over it, it will actually show that the non-volatile memory is not in sync with the running configuration. So what we're going to do is we're going to go ahead and save whatever changes we may have made. And when we do this, you'll notice that there's also a fingerprint for that configuration. And this floppy disk symbol here has gone away. So that said, I can now power cycle the switch. I can now put this switch on the shelf for days, weeks, months, and that configuration will persist. I can take this a step further though, in that we have backup storage adapters. So this is a little USB-C flash drive. This is specifically designed for our BRS switches. This can be inserted into the switch, and during the, let me do a quick refresh, you'll notice that the status is okay, and at this point in time what I can do is I can now save the configuration. When I save the configuration to the switch with this adapter in place, and this adapter is known as an ACA or automatic configuration adapter, it will then put a copy of the configuration onto this adapter. And you can see here, not only do we have RAM, this is our volatile memory, our non-volatile memory in the switch, and our external non-volatile memory. And when I save it with this configuration adapter in place, my fingerprint is going to be a complete match with the running configuration, and as well as the obviously stored configuration of the switch. So it is a very handy thing to have. We can also then utilize this adapter. If for some reason this switch were to fail, all I'd have to do is grab a spare, take this adapter, plug this adapter into the replacement switch, and during power up, that replacement switch will pull the configuration off of this adapter and clone itself. Optionally, you can also put a copy of the firmware on there along with a text file that points to that adapter or to the appropriate file or firmware file, and that spare switch will first look at the firmware, automatically update or automatically backdate its firmware. The switch will automatically reboot, and it will then pull in the configuration. So all one would need to do is unplug everything from the old switch, plug everything into the new switch, ideally in the same ports just in case any VLANs are set by port, and that is it. The switch is going to do everything else that it needs to from there on to clone itself, again, down to the firmware level if this is something that is needed or desired. This is also a great way of cloning switches. If rolling out multiple switches, it is simply a matter of taking this USB-C drive and plugging it into the first switch, creating a configuration, saving that configuration, and then unplugging it, plug it into the next switch, power up that switch. That switch is going to clone itself, and the only thing you then need to do is change the IP address because that too is going to be copied. Other things that we can do from here is we also have this feature called undo configuration modifications. If enabled, this is going to monitor the connection to my laptop, and if for some reason that connection gets severed, such as placing yourself in a different VLAN, and if this switch happens to be rather inaccessible, be it in another building, possibly in another state or even country, what's going to happen is after the default 600 seconds, the switch is automatically going to reboot and then come back online with its last saved state. So it's a very neat feature to have. The minimum value here is 30 seconds, and a high degree of caution needs to be observed when utilizing this function, because at the end of the day, if you've configured all of your switches, everything is great, and you have forgotten to turn this off, and you close your laptop and head home for the day, after whatever seconds this has been set for, that switch will then reboot. So do put a post-it note somewhere close by, preferably on your on the keys or on the laptop itself, to ensure that this does get turned back off. We also have the ability of putting a backup configuration onto a remote server. This would then be a TFTP server. The external memory itself, we can dictate whether it's going to do a software update or firmware auto update if one is on the flash drive. The SSH key auto upload, as well as a backup, or whether to actually put a backup of the configuration on this. This is easily demonstrated simply by disabling this, hitting set, then going back a screen. And if I now save the configuration to the switch is not going to put a copy onto the external memory adapter. And this is best illustrated by looking at the fingerprints, because the fingerprints are now different between what's in the non-volatile memory and what is in the external non-volatile adapter. So reverting that, I'm going to go back here, we're going to re-enable that. And if I were to go to load save, hit save, now my fingerprints should be a match between what's in the non-volatile memory and the external non-volatile memory adapter. And there we have a match again. Other things that can be done from here is you can, with the ports, you can name the ports. It is highly recommended that ports are named. The ports themselves can be disabled. You can keep the power on the port just for the sake of not triggering a link loss alarm, yet just stop all of the traffic to the port. All of this can be done. And from here you can also set the duplex of the port and other parameters. You're also able to look at the statistics of the ports. So anytime that there are questionable traffic performances on the network, this allows you to look at CRC errors, fragments, collisions, and any port that's indicating a increasing number of these happening. That is usually then going to be a port that should be suspect, either due to bad cabling, poor termination, or otherwise. You can then also look at utilization. You can alarm based upon thresholds, both upper and lower thresholds. You can, from here, then also restart the switch. You can delete the ARP table. You can reset all of your address tables and log files. Numerous things can be done from within here. Next, we also have, for time, we support precision time protocol if it's necessary, SNTP either as a client or server. For device security, we can create multiple users and define what they have access to. We have an authentication list. You can utilize 802.1x. For management access, we can dictate as to what IP address has access to the switch management and over what protocols. You can define the web timeout or the management interface timeout for the web management, and you can do the same for the CLI management. Under network security, we offer port security that allows you to dictate as to what MAC address is allowed to be plugged into this. We support 802.1x and radius authentication. We have a denial of service functionality. and we also support IPv4 ACLs as well as MAC ACLs or MAC-based ACLs. And these ACLs would then get assigned to either a port or a VLAN ID. Next we have switching. We have a rate limiter for both multicast and broadcast. We also support IGMP snooping. This is where we would do our multicast filtering, ensuring that we at least have one carrier on the network. Quality of service. We then can configure our VLANs here. Any layer 2 redundancy. So by default, spanning tree is on. And we also have, for layer 2 redundancy, a variety of other redundancy protocols, most notably MRP. This is Media Redundancy Protocol. It's an IEC standard. It is very effective and it is very simple to configure. It is simply a matter of turning it on, defining your ring ports, ring port 1 and ring port 2, could be any mix of copper and or fiber, and then just ensuring that one of the switches in the ring needs to have the ring manager on. All the others simply stay off. And for the most part, that's it. You then simply click on OK, set, and you're done. So it's a redundancy protocol that's very fast, very robust, and very industrial automation centric in terms of its functionality, because the fact that it will provide reconvergence times in under 30 milliseconds. We can then also do link aggregation. This allows us to aggregate multiple ports. So for example, with the BRS 50, the switch right here, which has 2.5 gig SFP sockets, we can create a 5 gigabit fault tolerant ring. We can do link backups. We can also do FuseNet. This allows us to create two separate rings that are redundantly coupled. We can also look at diagnostics, our status configuration, that initial splash screen or landing page that indicates the switch status is driven off of these three parameters in here. So at the very first screen, this one here, we have device status, security status, and signal contact status, and they're all driven from this right here. So looking at the first one, device status, currently if I look at the status, there are no errors. I can alarm based upon link loss. I can also alarm based off temperature, the removal of this adapter not being in sync, loss of ring redundancy, or any of the power loss on the switch, either power supply 1 or power supply 2. For security status, we have a few more items that can be monitored, and all of this can be tailored to the applications or the customer's specific need. So in this case, we are monitoring that the default password has been changed, that the minimum password length is greater 8 or greater, that the password policy settings have been are deactivated, and so on and so forth. So looking at exactly what it's currently triggering on, we can click on status, and we'll see here these are the alarms or the violations that have been met and are being reported. Next, we have our signal contact. This is the fault relay output, and I currently don't show an alert. And here too, we can alarm locally on the terminal block any loss of connection, temperature, if this is removed, if it's not in sync, the power supplies, ring redundancy, and here we are able to define which ports we're going to monitor, and if for some reason there's a loss in comms on that port, actually a very good one would be port 8 if we were to monitor that. And so if we were to monitor that And now if I were to go to connection, if you heard that click, and we have we don't show it, do we show a fault light? Yes, we show a fault light. If I look at my status, it's indicating that I've lost comms on port 8. And here too, if I look at my splash screen, and if I do a refresh, I show a fault. Other notable features, we obviously do not syslogs, we do syslogs as well. We do syslogs down here. So we can do syslogs, we can send syslogs to a syslog server or multiple syslog servers. But what we also do is we send out SNMP traps. This is where we would send the destination of those SNMP traps to. As an example, our NMS would be a recipient of that SNMP trap. The hardware state, ARP tables. Here we have that syslog screen. We can look at the SFPs specifically. So if we had an SFP inserted in here, we can, let me actually go find an SFP. So I've just inserted an SFP into here and did a refresh. It's a 100 meg SFP. It's a multi-mode SFP. Its temperature is 15 degrees C. It will show you the transmit power, the receive power, both in milliwatts as well as dBs. So it's a great tool to have in order to monitor the link quality over time. These are all available as MIB values, and these can be pulled and monitored for long-term monitoring purposes. We can also look at a twisted pair cable diagnosis. It will show us how long the cable length is. We can do port monitoring from here. If there's link flaps or CRC fragments, we can have a port automatically be turned off. From here we can also do port mirroring. We can monitor or mirror one port or multiple ports. This is our LLDP configuration. So if you have a multiple or multitude of devices and are also utilizing industrial high vision, our NMS will then be able to utilize this information to map or draw the network for you. Next we get to report and global. This is where tech support will frequently ask for your switch configuration and what we refer to as a switch dump. This is where you would click on this. It will then pull all of the data from this switch, all the log files, the audit files, the configuration, and so on, and it will then create a zip file, and in that zip file you will then have or be able to provide us with all of the necessary information that we may need in order to troubleshoot or help you troubleshoot your issues. We can do persistent logging. Persistent logging does require an external memory adapter like this, or in the case of this RSP, it might be an SD card. We have the log of everything that's gone on in the switch. We have an audit trail. We also have the ability of incorporating a DHCP server. The DHCP server can also be done by port. So it gives us a lot of flexibility, even VLAN ID. Other things that we are able to do is we're able to incorporate the switch management into a wide variety of automation vendors' software. So for example, for Studio 5000, we support the Ethernet IP SIP, and this allows you to, once enabled, you can download the EDS file for this and even allow Ethernet IP to write access or give Ethernet IP write access to the management interface. We can do the same thing for Profinet, for Step 7, for Modbus TCP, and for IEC 61850 MMS. Last but not least, we also have the digital I/O input. This can send a SNMP trap. Ultimately, what it's also going to be able to do is it's also going to be able to trigger an ACL rule or rules based upon that digital input. And last but not least, we have CLI. This allows you to open up an SSH connection, and our help. What's neat about our help is pretty much regardless as to where you are in the switch management, you can always click this little help button here, and it's going to give you page specific context for your needs. So right now we are in IGMP Snooping Querier, and it has taken us directly to that page or that section within this help file. So it doesn't give you the entire file to look through yourself, but instead it'll take you to exactly where you need to be and where you are looking help for. So all that said, I hope that this has been useful for your needs. Please feel free to give me a call if you have any questions. This has been a lot of information, but thank you very much for your time.